If the human race can build a ship that reaches 20% of the speed of light with this technology, a young crew, with astronauts between the ages of 20 and 30, could go to and from Proxima Centauri in a single lifetime. The only inconvenience is that when they return to Earth, 40 years will have passed, but on Earth, hundreds or thousands of years will have passed due to time dilation. According to the theory of relativity, the faster you move in space, the slower you move in time. For a group of astronauts traveling at speeds close to the light, time will pass more slowly compared to those of us staying here on Earth. While for them, a few decades will pass, and on Earth, hundreds or perhaps thousands of years will pass. In this sense, perhaps the best thing for the first astronauts to visit Proxima Centauri will be to do everything possible not to return, since by the time they return to Earth, all the people who knew them will already have died naturally due to the passage of time. Those who venture to explore the stars must pay a heavy price, never seeing their loved ones again. Considering this, would you dare to be the first human being to travel to Proxima Centauri, even with the cost that this implies? Let us know your opinion in the comments. Now, what will the first manned mission to Proxima Centauri be like? The first interstellar journey. What will the first Proxima Centauri voyage, the closest star to the solar system, be like? Will it be with a spaceship like the ones we have today, or with technology that doesn't exist yet? Who will be the crew members of that mission, and what challenges will be presented during the flight? Let's find out. When discussing interstellar travel, we must consider a significant factor. In the 21st century, we still do not have technology capable of traveling through the stars. The spacecraft that have gone the furthest in history are Voyagers, which have not yet made it entirely out of the solar system, and still have thousands of years to go to get out. In addition to the fact that our spacecrafts cannot yet travel long distances quickly, we also do not have efficient propulsion systems. Parker Probe. The Parker Probe is a spacecraft that NASA launched in August 2018 to study the Sun and its corona. It is the fastest spacecraft ever built by humans and has managed to break several records in its short lifetime. In November 2021, it became the closest spacecraft to the Sun, surpassing the previous record held by the German Helios 2 spacecraft, which had come within 26.55 million miles of the Sun. Parker also set a new speed record in April 2021, reaching 330,000 miles per hour on his closest approach to the Sun. It is hoped that with the help of the gravitational assist of the Sun, the Parker Probe managed to reach 430,000 miles per hour. But even this fantastic speed is still not enough to venture to the stars. To reach these high speeds, space probes use gravitational assistance, a technique used in space exploration that allows spacecraft to take advantage of the gravitational force of the planets or the Sun to modify their speed and trajectory. For example, suppose a spacecraft is approaching Jupiter. In that case, it can use Jupiter's gravitational pull to increase its speed and send it on a trajectory that takes it further from the Sun. As is evident, this acceleration method only works if there are planets or stars in the way. But space is mostly empty. There is nothing between one star and another, so this type of propulsion does not work for trips beyond the Sun. As you have already realized, the main problem for the first human crewed mission to Proxima Centauri will be propulsion. If we do not have engines capable of generating enough power, the trip could last thousands of years. In this sense, we could wait a couple of decades or centuries to see how space travel technology progresses in the future. In this way, the trip to Proxima Centauri could be the following two options. 1. A speedy voyage of a couple of decades in which the crew that arrives can return to Earth. 2. A long journey in a generational ship with humans who will spend centuries or millennia living in space until they reach their destination. One, travel with a return ticket. In the first case, we have the most optimistic option of all, a round trip at superluminal speeds, where we can build a spaceship that reaches up to 10% or even, in the best of cases, 20% of the speed of light. With this speed, the trip to the Proxima Centauri star would take approximately 20 years, which is a long time, yes. Still, it is much more reasonable than a trip that lasts thousands of years. Today, we have no way of reproducing this speed in a spacecraft, although many scientists believe that this speed could be achieved with pulsed nuclear propulsion. In a pulsed nuclear-powered spacecraft, nuclear explosions would propel the craft into space. Each explosion would create a shock wave pushing the ship in the opposite direction. The spacecraft must be designed to withstand the extreme forces generated by these explosions and protect the crew from radiation. One of the main advantages of pulsed nuclear propulsion is that it can generate a large amount of power from a small amount of fuel. This means the ship could be lighter and require less interplanetary or interstellar travel fuel than other propulsion types. Additionally, pulsed nuclear propulsion would allow spacecraft to reach speeds much higher than those achieved by other propulsion technologies, which could significantly reduce travel time. However, pulsed nuclear propulsion also presents some significant technical and safety challenges. One of the biggest problems is controlling and directing the energy released by nuclear explosions. The ship must be designed to withstand the extreme forces generated by these explosions and protect the crew from radiation. Additionally, using nuclear materials in a spacecraft may raise safety concerns and contamination risks in the event of accidents or failures. Despite these challenges, pulsed nuclear propulsion remains a promising technology for long-term space exploration. The most reasonable thing is that the spacecraft that makes the first trip to Proxima Centauri takes with it everything necessary to establish a base in the possible habitable planets that the astronauts find. One option could be the exoplanet Proxima B, which orbits around the star Proxima Centauri. It is still debated whether this planet could have the necessary conditions for life. But if not, we could carry everything necessary to terraform it and make it the new home of the human race. Number 2 is to travel without a return ticket. If it becomes impossible to reach such high speeds, even with the advancement of technology in the next few years, the only option left for us would be a mission that lasts several centuries or millennia. To withstand such a long voyage, the first option would be to put the entire crew in sleep pods. This has been seen in science fiction movies like Alien or Passengers. This technology consists of placing the passenger in an indefinite artificial coma that keeps the body protected from the passage of time, and then wakes up when they are about to reach their destination. What are your thoughts about this? Let us know in the comments. Thank you for watching the video until the end. However, sleep pod technology is still not fully developed, and some risks are involved, such as the possibility of brain damage or long-term health problems. It is still unknown if this type of technology could ever exist one day.